I am so excited to be here. I flew in yesterday evening, and I had intended to be here all day, but I kept falling asleep as I tried to leave my hotel room. But I'm here now, and I did bring a whole bunch of stickers with rainbows and unicorns and snarky sayings about systems. So find me afterwards. Oh, and for those of you who have the book, the Observability Engineering book, I have a bunch of the cover art stickers too. So if you have the book, I'll give you the stickers and then it looks better. All right, my talk is about CI/CD, which I don't know if it makes your eyes glaze over yet, but I feel like we've been talking about this for 15 years now? So what could there possibly be left to talk about? Oh, I added a dragon at the last second. I love the theme. Oh my God. I just wish I had the little, oh my God, the head. You put the head on. The head and the wings are amazing. All right. Thank you for the intro. I guess I don't need to introduce myself, but I will point out the book, which is out of early release, so I should update that. And it's available for free. We tweet it out occasionally from the Twitter account for Honeycomb. So if you don't have it, you don't have to pay any money for it. So, how well does your team perform? This is a question that I hear, well, I wouldn't say I hear it a lot, but it's the undercurrent for a lot of things that I hear, right? Especially with the economic downturn, there's a whole lot of, it's time for us to justify our value, and like the build versus buy thing is becoming hot news again, which I think, maybe I'll get a time to talk about this a little bit. It's not in my talk, but I think this is really good for us. I think this is great. I think that not being able to articulate our value has often kept CTOs from being, and VPs of engineering from being equal players in the exec teams. I think that our inability to articulate and quantify our values has left us relying on gut feelings and intuition when it comes to what should we spend our time on, what should we build, what should we buy. I think it's made us weaker as an industry. I know we don't like to talk about converting our work into dollars because it makes us feel ishy, and it's never exactly true. But I feel like learning to speak about our work in the universal denominator of dollars, or pounds, as you may prefer, I think it's going to be hard, it's going to be challenging, it's going to push a lot of our buttons, but I think it's going to make us a lot better as engineers. All of that aside, I think it's super important to say that how well does your team perform is not the same thing as saying how good are we at engineering. It's not. It is not entirely unrelated, but it's less related than I think most of us may think. High-performing teams, the way I define them, are teams that get to spend most of their time doing interesting stuff. Solving interesting, novel problems that materially move the business forward. And how many of you self-identify as infrastructure engineers? Yeah, me too. We're a little late to the party when it comes to this whole move the business materially forward concept. I remember having a lot of long, passionate arguments about whether we should outsource Kafka or not that made almost no mention of how good it was for the business or not. But as I've gotten older, I have learned, parse is the catastrophe that taught me this, that no matter how fun the work is, if it doesn't ultimately get used, if it ultimately gets shut down, you feel like shit. Sorry, is this a clean or PG-13 sort of room? Oh, right. What am I thinking? All right, parse is fucking bullshit, man. Jesus Christ, what am I thinking? All right. Lower performing teams get to spend their time doing everything else. Fighting with their tools, fighting with each other, yak shaving, and toil. And when it comes to how high performing your team is, this is where, I know Nathan Harvey's going to be talking a lot about this later, this is where the DORA metrics come in. Whoops. How frequently do you deploy? How long does it take? How often does it fail? How long does it take to recover? And well, I think all teams should be tracking this stuff. If you're an engineering manager and you're not tracking this stuff, what are you doing? I also think there's one more that everyone should be tracking, which is how often are you being alerted outside of work? Because being alerted during work time is annoying. Being alerted out of work time is soul-crushing. Being alerted during work time, if you're following the best practice that I advocate, which is while you're on call, you are not held accountable for doing any project work whatsoever. That is your team's 20% time to be spending investing on the system itself. And in that case, being alerted, it's annoying, but like that's what you're there to do, right? But alerting people, and especially I feel like in this brave new world where we're trying to bring developers into the world where all engineers are carrying pagers for the work that they do themselves, I feel like, a lot of us have gotten numb over the years as ops people. We can take a flappy page or two. We're going to burn these poor delicate creatures out if they have to take their pink little paws and answer a pager at 2 a.m. There's a lot of parallels here to how I feel about, feminism, which is that I didn't grow up being sensitive, but I have learned to become sensitive on behalf of others because it's important. There is a huge gap between elite, I hate that word, elite, feature requests. Could we change it?
It's gone.
It's gone?
It's gone.
Woo!
That was easy. Every feature should be that easy to
ship. Yes. I like to call them high performing, but between high performing teams in the bottom half, and I know my slides are not up to date. There's a new slide. You'll see it from Nathan, whatever. These quote unquote elite teams, they deploy whenever they need to, several times a day. Whenever someone is around and feels like deploying and commits to being there long enough to make sure that their change is working, right? Whether it's Tuesday or Friday, what matters is the follow-up and having a healthy organization, not what time or when. And again, this is not a question of the best of us versus the rest of us. Some of the best engineers I know of are working way over there on teams that deploy once a month. You know why? Because it's fucking hard. Do you know how good of an engineer you have to be when you're deploying constantly? Not that great. You know how good of an engineer you have to be when you have to deploy twice a year? Really good. But all of that amazingness of your engineering skills are going to toil and shit that is not moving the business forward. You're sitting there like bailing water by hand instead of hooking your ass up to, something that uses electricity. And the gulf is big, and it is, the last time I looked at it, it is getting bigger, which means that it really, 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 really pays. This is something, if you're looking for work, this is something you should be grilling your interviewers on to try and figure out how high performing is this team that I'm about to join. Asking them things like, how does a feature get built and shipped? Is the simplest, most straightforward, and yet most complicated answer in the book, right? If they can't tell you, that's a problem. If they can tell you and it takes 2 days, well, that's a problem too. But being on a high-performing team matters because this is how you get better at your job, right? If you're shipping many times a day, you learn a lot faster. You become a much more powerful engineer. And how do you how do you make these high-performing teams? It's been drilled into us that the answer is hire from FANG companies, right? But this is, I'm sure everyone in this room knows that this is false, right? Because great engineers don't make great teams. Great teams are what make great engineers. Look at it. I mean, these are 2 kids who just graduated, right? The one on the left gets to deploy thousands of times per year. Has a few outages, spends some time firefighting, but most of her time is going towards moving the business forward. And she's learning constantly. And this poor kid on the right, gets to deploy and learn only a few times a year. Constantly firefighting. What happens when an engineer from a high-performing team joins a team in the blue bubble? I feel like as hiring managers, our fantasy is that they drag everyone up with them, but that's not how it works. You can be the best engineer in the world. If you join a team that takes 2 months to ship a fix, it's going to take you 2 months to ship a fix. The structure, the sociotechnical structure defines how good of an engineer you are allowed to be, how much progress you are allowed to make. That's why your productivity tends to roughly rise or fall to match that of the team that you join. Your ability to ship code has some to do with your personal knowledge of data structures and algorithms, But mostly it has to do with the sociotechnical system that you are participating in, which is why, as technical leaders, and every single person in this room is a technical leader, so not just a manager talk, right? Some of the best changes, some of the biggest changes get driven by the people who are doing the work. Technical leadership consists of focusing intensely on those feedback loops that are at the heart of your system. Code reviews, deploys are a big one, right? Anything that feeds back into itself. I'm sure everyone's familiar with the term sociotechnical by now, but it's just what it says in the label. It is a system that is both social and technical. And I think that we hear this and we agree, but we tend to underthink everything that precedes from that. We think of the sociotechnical system as being, okay, you've got production, you've got your artifacts, you've got the tools, that are enacting changes upon the system, and you've got the people. But the people are not like robots pushing levers. Most of the information about your system lives in each of your heads. Like you couldn't just take the engineering team of the Washington Post and the engineering team of the New York Times and just swap them overnight, even if they're running basically the same system, doing basically the same thing. It lives up here, which is why so much of what we try and do is focused on the systems, the feedback loops of getting the information out and getting the information in, and putting a hard copy on disk somewhere with some notes. Also, they call this the fundamental attribution error in sociology, which is that we chronically overestimate our own personal influence upon the system, and we underestimate the influence of the system upon us. Also, we waste a lot of time, like so much time. Oh my God. If you haven't read the Strike Developer Report, and if you're ever looking for ammunition when you're trying to convince management that you should spend time working on these socio-technical systems and feedback loops, DOOR report, yes. And the Strike Developer Report is unreal. We self-report that we waste 42% of our time on things that don't bring any business value. It's the shit you have to do in order to get to the shit that you want to do, which should be as small a pile of shit as possible. Which brings us to CI/CD. Any intercom folks here? Ah, man. This is an intercom quote. Shipping is the heartbeat of your company. And I love it because it's so true. You want your heartbeat you want it to happen often, fairly regularly, and you want it to be no big deal when it happens. That's how you should feel about deploys. They're a nothing burger. You write some code, you merge it, you know it's going to get deployed within a few minutes, right? And so you're going to go look at it. You can just depend on it. You don't have to do anything special to make it happen. It just happens. And CI/CD is how we get there. Fear and loathing around deploys is the single largest source of technical debt in almost every organization that I've ever seen. And I didn't say that deploys are the biggest source of technical debt. Fear and loathing of deploys. It's the fear that tells us, well, we're not good enough to deploy in this amount of time. We can't ship to production without 15 different staging environments and QA sign-offs and spreadsheets, and we can't do these things because we're not good enough, because we aren't Google. That's a Google thing. That's a Facebook thing. That's a Honeycomb thing. They hired the best engineers in the world, so we don't get them. We can't do that. It's bullshit. It is bullshit. So when you're asking people, everybody does CI/CD these days, right? Anyone you talk to is pretty much going to say yes. And then you start asking some questions. And it's like, well, we definitely run some tests. Absolutely run tests. It kind of runs automatically, breaks a lot. Yeah, sure, we're doing CI/CD, which is usually true if you're focusing on the CI part. But CI is only the main, CI is not the main course, it is the prelude to the main course. The entire point of continuous integration is to clear the path for you to do continuous deployment. I did not say continuous delivery. Delivery was a cop-out word that they used 15 years ago because they didn't have the tools and the instrumentation and everything that they needed in order to safely do continuous deployment. Continuous deployment is the way, the truth, and the life. It will save you, it will change your life. Even if you don't get there all the way, keeping your eye on that prize will lead you in all the right directions. I mean, honestly, if you aren't going to hook CI up to production, why even bother? Just run your tests on your laptop. It's the same thing, right? Less hassle, breaks less often. It matters that you connect CI/CD to production and that you make the final step of CI/CD a deploy. Now, at Honeycomb, we do not deploy directly to production. We're not crazy. We're an infrastructure company. We have customers that rely on us. We take that reliability incredibly seriously. What we do have is we have production, then we have a dog food environment. So all of the instrumentation where we've instrumented production goes to our dog food environment. And then all of the instrumentation from dog food goes to another cluster we have called kibble. So both of these clusters are in constant use, right? Production is being constantly used by our customers. Dog food is constantly being used by our engineers, introspecting our system and understanding it. And kibble is used too, sometimes for like debugging our dog food cluster stuff. But we auto-deploy to kibble. And we've got some checks there and stuff. And if there have been no problems, then after an hour, it gets automatically promoted to dog food. And we've used that constantly, so we'll find things there. And after an hour, if nothing's happened, it gets promoted to production. But the point is, auto-deploying to something that nobody uses that's not good enough. It has to go somewhere where real users are using it, because real users are the trick here. It's not just bots. It can't just be bots. If it's just bots, it does not count as, it isn't production enough to count as production, right? There are many layers to production. It doesn't have to go directly to production, capital P, in order to get auto-deployed to production where real people are using it, because real people, as we all know, bring the chaos. I would go so far as to say this: any CI/CD job that ends without having deployed your code was a failed run. So if we're going to try and get to this place where we trust, and absolutely we cheated by doing this from the beginning. I think on day 6 of Honeycomb, I was like, I'm tired of hitting deploy, so I'm going to write a shitty little bash script that it looks for once an hour if there's a new artifact that's been published, and I'm going to just yoink it down and roll it out. Absolutely, it's easiest to grow up this way. You know, it's like binding your feet. That's a terrible analogy. It's like Alexander the Great as a child, whose father had him lift his pony every morning before breakfast so that when he was big and tall and strong, he could lift his horse before breakfast, right? It's easiest if you grow up that way. And a nice way to start is by, when you're spinning up a new service or something, starting that way and increasing your confidence as an org. Doesn't mean it's impossible, though. It's just easier. So what does a good feedback loop look like? I'm talking all this stuff about what you should be able to do, right? Well, this is what it looks like. You merge a change to main with user visible changes safely hidden behind a feature flag. Feature flags are a must in this world, which triggers CI to run your test, build an artifact, which then gets deployed or canaried to some place with real users using it in ideally 15 minutes or less. This is actually an hour for us now because we added all of the additional. Well, there's blah blah blah. The point is, I honestly think that it's more important that it be a predictable amount of time than it be a very short amount of time, and it's very very important that it be that this be happening regularly enough that more or less it's one person's changes at a time going out. Because if it's predictable, if your changes and a bunch of other people's changes are going out at some point in the next hour, day, or week, none of you are ever going to go look at them. You're just not. You don't know where, you don't know when, you don't know where. But if you know that your changes and your changes only are going to be out within an hour, you're going to go look for it. You're going to literally get, after you do it a bunch of times, you're going to get the feeling in your body that you're not done yet until you've looked at it, right? That feeling in your body that, it's time for me to go check on my changes. I'm going to go check my changes. Now I'm done. Now I can switch gears. That's what you want. You want predictability. one change set per engineer, per build, ideally. No manual gates, no manual QA or variable times. The real problem with those is that they add variability. It's not going to be predictable. And feature flags, which is how you decouple deploys from releases. And as the Mandalorian would say, this is the way. Because that time between when you wrote the code and when the code is somewhere that you can watch real users using it, that interval is everything. It is the difference between toil and fulfillment. It is the difference between happy customers and lost ones. It's everything, because again, so much of the socio-technical system lives here. And our memories are not that great. We've got, after you've written the code, you know everything about it. You know why you did it. You know what you tried. You know what you tried that didn't work. You know what you named things. And like closing the loop and looking at it as real users use it in production before you've lost that is really the key to catching problems before they, the cost of finding and fixing bugs. I don't think I have this in my slides, so I'll just say it goes up exponentially from the moment that you write them. You type a bug, you backspace, great, good job. It's fastest anyone's ever fixed it, right? You find it in CI, great. Third place you can find it is right after it's been deployed. When you go and you ask yourself, you look through the lens of the instrumentation you just wrote, and you ask yourself, is it doing what I expected it to? And does anything else look weird, right? You can find 85% or more of bugs, like right then and there. There's math behind this. I'm not just pulling numbers out of my ass, I swear. If you remind me, I'll post them on the internet later. But that's everything, because if you've had a few hours, you're not going to sit there and wait for your shit to go live. You're going to change gears. You're going to page all that out, and you're going to page a new project in, and it's going to be lost, and it's lost forever. You can never really get it back. I actually have stickers that say undeployed software ages like fine milk, so find me after class. Oh, I did say some of this stuff. There you go. I got going on a rant and I didn't remember. A short interval also lets you hold the line against batch deploys, which is really how you can say with a straight face that you have software ownership. Otherwise, it starts to get grim pretty fast, because if it takes you hours or days, you're definitely batching together changes and not deploying automatically, which brings us to what I think of as like the software development death spiral. You're always either in a virtuous feedback loop getting better or in a death spiral getting worse, because software is not static. It exists in a state of entropy. It is constantly getting worse on you every single second, unless you are working to make it better. But the death spiral looks like this. There's a longer interval between when you write the code and it gets deployed, which leads to larger diffs, longer code review, more time spent paging projects in and out of your brain, changes getting batched up, which means that nobody has ownership over their changes, not really, which makes it really hard to identify which code isn't working, which means that you spend more and more engineering cycles trying to figure it out, and more cycles waiting on each other, which now means that you need some specialists. Maybe you need to hire a separate SRE team, a different build team, another product team, because you can't move quickly enough. And this all incurs more coordination costs. Now we need more engineers, managers, and project. All of this costs more time. Have you ever looked at an app and gone, oh, cool app, I'm going to check out the company. They have 800 engineers? That's why. This is how that happens. You can have so many good to great engineers in a system where they spend almost zero of their time making measurable progress against business goals, because they're all fucking waiting on each other, and they're all waiting for the system to do other stuff so that they can do the stuff that they want to do, and then they have to wait some more. I mean, you can spend your entire life just chasing symptoms and pathologies and all the stuff that falls out of these crappy systems. Or you can fix it upstream at the source by auto-deploying to production in 15 minutes or less. And so I did some back-of-the-envelope math to try and figure out how much is your fear of continuous deployment costing you? And rule of thumb, which again, this is pulled out of my ass, but on the other hand, I have validated this at many companies I've ever worked at, and I've talked to other people who have said it sounds like the numbers that would come out of their ass. So, science. The rule of thumb is basically, if it takes X number of engineers to build, maintain, run your software systems with, let's say, under an hour delivery interval, it will take twice as many engineers if it takes you up to a day. If it takes you multiple days to ship your software, double the engineers again. And weeks, double them again. If anything, I am underestimating this because the cost of finding and fixing bugs, which it's not just it's trying to understand your systems that takes as much time, right? It's everything involved in understanding your systems. Does not go up linearly, doesn't just double, it goes up exponentially, right? We're wasting a lot of money and we're wasting a lot of people's time. And it's not just about the economic arguments, right? Like bringing it back to the question of how well does your team perform. High-performing teams get to spend... Software engineering can be such a creative, fun, wonderful... You get to solve puzzles for work, for money, for lots of money. Like, it's a great job. But it can feel like ass when this is how you spend your time. Which means that, this is a quality of life issue. Which means that this is ultimately an ethical issue. And it really helps when it comes to hiring and recruiting and retaining good engineers. Nobody who's worked with real continuous deployment is willing to go back. And I feel like this is a mission that we should all be able to get behind, right? Nobody would disagree with any of these things. The question, of course, is how we get there. And building high-performing teams that are low in toil, high in autonomy, mastery, and meaning starts with hiring people who share your values, constructing and tuning these sociotechnical feedback loops. This is the job of every senior-ish contributor. It's not a manager's job. It's not your principal engineer's job. It is your job. Adding instrumentation and observability. Got to put your glasses on before you go driving down the freeway. Practicing observability-driven development and repeating. So in the end, the real question is, are we too busy to improve? The end.